Hi, I'm Patrick from 7bitwonders, and today we're solving the problem breed counting from the USACO 2015 December contest in the Silver Division. Farmer John's and cows conveniently numbered from 1 to n are all standing in a row. Each cow has a breed ID, 1 for Holsteins, 2 for Guernseys, and 3 for Jerseys. Farmer John would like your help counting the number of cows of each breed that lie within certain intervals of the ordering. The first line of input contains n and q, both up to 100,000. The next n lines contain an integer that is either 1, 2, or 3, giving the breed ID of a single cow in the ordering. The next q lines describe a query in the form of two integers a and b, a less than or equal to b. For each of the q queries, we need to print a line containing three numbers, basically the number of cows numbered a to b that are Holsteins, Guernseys, and Jerseys. The first idea we'd have, which is also the naive implementation, would be for each Q queries to sum up all the cows in the A to B interval and then give our answer. In the worst case scenario, we would have to do this at most n times. So the final time complexity would be O of n times Q, which may fly for bronze, but because both n and q are up to 100,000, we would have at most 10 to the power of 10 possible operations, which would be too much. If we read this last line, we can assert that this is a direct application of the prefix sum strategy, repeated 3 times basically, because we have 3 types of cows. If we use prefix sums, we can answer the all Q queries in constant time, which would reduce our time complexity from n times q to n plus q, which is the best we can do for this problem, with of course an auxiliary O of n complexity for space. That is basically the whole gist of the problem. So let's jump straight into the implementation details. So the implementation is as straightforward as we've seen. Our first order of business should be creating the prefix sums, which I've decided to write it like this. An array of vector of ints of size 3 called cows. 3 is for each cow ID, and a vector of int, I've chosen it so I can dynamically, resize the vector and use less space if need be. We can also create an q, the cow breed ID, and the interval heads. We can read the n and q. And now we should basically resize all the prefix sums for the cows, index them at 1, and initialize with 0. We repeat it 2 more times in the same fashion. Here is why we've chosen to implement the prefix sums like this. After we've read the cow ID, we can say cows of x minus 1, because it's 0 indexed, of I plus plus. So for that particular cow breed, we can mark the fact that we've seen it, and to complete the prefix sum for all IDs, we add the previous sum at I minus 1. And that's it. As you can see, this problem is nothing to write home about. It's interesting if you haven't learned previously about prefix sums and this is your first problem. It's, good practice, but otherwise, absolutely no difficulty from it. I minus 1, and cows of 2 of I plus equals cows of 2 of I minus 1. So, up until here, we have completed 99% of the problem. We just have to answer the queries. We read the interval heads, and as we've learned from prefix sums, the amount of cows of a particular breed in that interval is cows of, its breed ID of B minus cows of that breed A minus 1. And that's it. We can copy and paste 2 more times. We just modify the breed ID. And here at last, we should put an end line. And that's it. We can run the code and see that we get the same answer like the example. So let's run the code and see how many points we get. Let's see how we've done. And as you can see, we have all greens. So that's basically this whole problem. There was nothing particularly challenging about it, but I see it as a, good exercise if you've just learned prefix sums and want to, directly apply the principles, without fearing, other constraints. That's it for today. If you have any suggestions, don't forget to leave them in the comment section below. Like, subscribe, and I'll definitely see you in the next one. Bye!